So we have June 2021. And the question reads, the scores of a class of 30 students on a mathematics test were used to draw the box plot below. Using the box plot, determine the following. So let me just make this a little bigger here. So we want to use that box plot to determine the median score. So we could get some information from the box and whisker plot, right? So we could find the median. So go ahead and read off the median from the box and whisker, Shazan.
That's 11.
11. So this middle value here is the median. And this will be 11. So the median score is 11. We want to find the range of scores and the semi-interquartile. So let me look at the range first. So the range is the highest minus the lowest. So work out the range for me.
Next 16.
Yes. 20. And this is the lowest. So it's 20 minus 4, which is 16. So we have the highest, we have the median, and we have the lowest. Now we are going to find the semi-interquartile. Which is a half of the upper quartile minus the lower quartile. Okay, good afternoon.
Afternoon.
So we're doing a continuation of the stem and leaf and the box and whisker plot. This is June 2021. So we want to wrap up this and then we want to go to probability. So part 1 was the median, part 2 was the range, part 3 is the semi-interquartile. So go ahead and see if you could get an answer there. Did you all get that answer? 17 minus 7 divided by 2, which is 5.
Yes, sir.
Yes, sir.
No problem. So there we go. Comment on the shape of the distribution of the scores. So what we can say that, so we want to comment on the distribution of the scores. So work out for me Q3 minus Q2 and Q2 minus Q1. Work out that for me. All right, let me know what you have. So 17 minus 11 is 6, and 11 minus 7 is 4. Did you all get that?
Yes, sir.
So the first thing is the data is not symmetrical. We could see that. We could also see the median is closer to the lower quartile. All that we can see from the graph, we can say that since it is the distribution is not symmetrical, right? And it is mean is closer to the lower quartile, right? Then it is skewed to the right. So if it is skewed to the right, that is called positively skewed. So data, when the median, is closer to the lower quartile, the median, the graph itself is said to be positively skewed. If it was the other way around, it would have been negatively skewed. So the graph would have been something like this. Right? So this is positively skewed. So any one of those, you'll be able to get the mark. The data is not symmetrical, or we could say non-symmetrical. We could also say, just by looking at the graph, this here is smaller than this gap. So therefore, the median is closer to Q1, which is the lower quartile. And if it is closer to the lower quartile, then it is skewed to the right, or what we call positively skewed. So take that up. All right, let me know when you wanna finish, right? Are we finished writing?
Examine.
Okay, finish writing.
Yes, miss. Yes, sir.
So I have some questions for you to think about. All right, so a student wants to determine the mean score for the data set. State one reason why it would be impossible to determine the mean, and state what additional information will be needed to determine the mean. Go ahead and work out 5 and 6. Do this one for me and this one. You could work out the standard deviation as well. So the formula for standard deviation is the square root of the sum of minus x bar. From the question, the sum and you have to find x bar, which is the sum of x divided by n.
Yes, miss.
Finish? The
Yes, sir.
standard deviation as well.
No.
Well, you could do the standard deviation. I give you the formula and I give you the information there. All right, let me know when you are finished. All right, are we finished?
Almost finished.
No problem.
Finish, miss.
All right, Shazad, are you finished?
Yes, ma'am.
All right. Shazad, what is one good reason why it would be impossible to determine the mean scores from the box plot? What information is missing?
Unless you block what the register only values executed, okay?
Yeah, so we don't have the raw data, or we don't have the box and whisker plot. Makaya, what additional piece of information would be needed to determine the mean?
Let's the rest of scores, the
Yeah,
rest of individual scores.
the individual scores.
If you have the total of all the scores,
If you have the total of the scores, yeah. If you don't have, yeah, the total of the scores,
okay, ma'am.
given the sum of 30 scores for the class is 354. So 354 divided by 30, how much is that? 11.8.
11 point.
Very good. So 4994 divided by 30 minus 11.8 squared. So this is the square root of 166.6 minus 139.24. The answer that I have is 5.23. You all got that?
Yes, miss.
Okay.
And that is the end of that, right? So let me move on. So we didn't have anything in 2020. That was the year of COVID. Right, so we go on to the next one, which is the 2019. 2019. All right, so this is June. The weight in kilograms of students in grade 5 class are displayed in the following stem and leaf. Say the number of students in the class and construct one box and whisker plot for the entire grade 5 boys and girls combined. So I'll give you a couple of minutes. Go ahead and draw the box and whisker. How many students are there in the class?
That's 29.
29 students. Now, in order to construct this box and whisker, we have to merge all the boys and all the girls using 2, 3, 4, and 5. How much you all got for the lower quartile or Q1?
That's 32.5.
32.5. So on your diagram or on your graph,
Let's see here, man.
yes, Makaya, hearing you.
My cousin Kepal.
You got those values?
Yes, miss.
All right. So all right, the graph's supposed to look something like this. Did you all look at that?
That's it.
All right, Makaya, got that?
Yes, miss.
All right, there we go. The standard deviation of the weight of the boys. So the standard deviation of the boys is 5.53 kilograms. Determine the standard deviation of the weights of the girls. Provide an interpretation of your answer for the girls compared to the boys. So, we have some working to do. So the girls, we had to find the mean, which is X bar. So you're adding 29, 28, 28, 29. Then you add in 32, 32, etc. That will be your X bar. You divide it by 14 because I think it's 14 girls. And then we had to find the standard deviation, which is the X minus the X bar. So let me work out the mean first.
That's 35.4.
35.4. Yes, that is correct. Did you get that, Shazad?
Yes, sir.
All right. So we had to do, well, the X minus X bar. So we could do that in the calculator, you know. You could put 28 minus 35.4 squared plus 28 minus 35.4 squared plus 29 minus 35.4 squared plus 32 minus 35.4 squared plus all the way down to 42 minus 35.4 squared. When you get an answer, divided by 14. So you can put everything in calculator, just take your time.
Finish.
All right. All right, 100 did you all get?
$23.37.
So the sum of x minus x bar squared is 23.37. Shazad, you got that? It's still,
That's the weekend.
still working, all right. I check it back, eh? Okay, how can you do that so fast?
It's very easy. Have a function on my calculator. We can just copy and paste our equation back and forth.
Oh,
Just are changing numbers at the start.
okay. What is that, the Texas Instrument or what?
So I don't know.
What is it in my calculator, Makaya?
It's some Chinese name.
That doesn't help, eh? So since you work it out, I want you to think of a reason, right? Why the question says, provide an interpretation for your answer. For the boys, standard deviation compared to the girls. So think about it. Right? This
Miss, what question want to do? Like, say why I think it's different.
you can say, talk about the standard deviation of the boys compared to the girls, right? The boys is 5.53 and the girls, well, they have that answer. Shazad, let us know when you're ready, right? Shazad, got 23.37.
Okay.
So if it's 23.37 divided by 14, then for the boys, the square root of 23.37 The girls, their standard deviation is 4.83 kilograms. Now it's 5 marks, so that is why probably they ask you to do all that working. So they ask for an interpretation of the weights of the boys compared to the girls. Right? So just all right. So what is the first thing that you could see about the standard deviation of the boys and the girls? What is the first thing that you could see with the figures? Anybody?
The boys are heavier.
Right? So the standard deviation of the girls is less than the standard deviation of the boys. Well, that is obvious, right? Because the figures are less, right? So it means a smaller standard deviation. It means that the data is less spread. This means that the data of the girls' weights is less spread out compared to the boys. You all had anything like that? What reasons you all had? Or closely?
As I say that the time division was less for the girls because it had more values for the boys.
You have more values for the boys? Okay. What you
For
have?
larger.
A larger arm. All right, no problem. Shazad, what you have?
Masang weekend.
You didn't do the interpretation yet?
No.
All right, no problem. In the meantime, Makaya, let us give Shazad a couple of minutes. You determine the number of students in the 20th percentile. So let's give him a couple of minutes to finish up. All right. Shazad, let us know when you're ready. Makaya, have an answer.
Oh, so
No problem. Shazad, how are we going about finding the 20th percentile? Shazad, how do we find the 20th percentile?
Next, I'm not too sure, but I found 1/5 of 29,
Right. So it was
and then subtracted it.
right. And you got how much?
5.6.
5.6. Right. And what you did with that now?
So, I minus that from 29.
Uh-huh.
So I got 23.4.
How much?
23.4.
26.4?
23.4.
23.4. All right.
Yeah.
Makaya, what did you do?
I said already number of students
All right.
from the computers and then find the 20th percentage and then round it up to 3.
Where you get 3 from now? You find 20 over 100, the 20 over 100 by 29.
My mistake, I must have like 40.
Okay, no problem. So Shazad and Makaya, to find any percentile, 50th to the 7th, any percentile, you put that number of 100 and you multiply it by the number of students, right? They didn't specify, it wasn't gender specific. So number of students is 29. This would have given us 5.8, which is approximately 6. So they want the number of students in 20th percentile. So we had to order the numbers. 28, 28, 28, and 29. So 28, 28, 28, 29. So that is the 4th number there. Then we have 32, 32. So the number of students, so this is 1, 2, 3, 4, 5, 6. So this would have been the 6th value. And the number of students would be more, who would be, the score is more than 32, will be 22, would be 22 since they have scores of 32 or less. So we have 29, right? So if it's 6, could be 32. So then they could subtract it. What value you get, Shazan?
Well, I got 22 because it's on the 12.
All right, that's not right. That's not. I know you had a subtract it. Just check something. So the number of students who scored 32 and less. 32 and less. Let me go back here. 32 and less would be 1, 2, 3, 4, 5, 6. The sixth value is 32. So therefore, the number of students who scored more than 32 would be 23. So your answer would be correct, Shazad. So roughly 32 minus 6. No. 32 minus 6. 26. Let's see. 1, 2, 3, 4, 5, 6. So we have 1, 2, 3, 6, 7, 8, 9, 10. 16, 17, 18, 19, 20, 21, 22. So it's 29. So 22 minus I'm gonna add the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So the answer here would be 22. So the number of students in the 20th percentile of the class, because 6 students would have scored 32 or less. So the students who would have scored more than 32 would be 22. You all understand that?
Yes, sir.
So that you understand that?
And the thing is total 29.
What did you say?
And then it's total 29.
Yeah, the total 29.
And if 6 got 0,
Yeah, so it's supposed to be 23 then.
yeah.
But remember the 20th percentile, we round off that to 6. But if we count it, 32, right? Shazad, we have 2 numbers as 32. So if we have 2 numbers as 32, then it will have 22 persons with more than that. You understand?
Okay.
Because this person here, the 6th number, 1, 2, 3, 4, 5, 6, or unless I'm missing somebody, just now, 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 20, 21, 22, 23, 24, 25, 26, 27, 28. Oh, I'm missing somebody. So if I'm missing one, then yes, you are correct. So along the way here, I think I missed out somebody. So it was the numbers. Let me see. 8, 8, I missed out a 9. So this would be 1, 2, 3, 4, 5, 6. But still, Shazad, it is 32. Both numbers are 32. So therefore, all these persons here would have scored a mark more than 32. So we can't count them. It have to be all these persons here, which would be 29 minus 7. It had to be 29 minus 7 because we can't, there's no way we could include that, that value of 32.
Okay, miss, I understand.
Yeah. So we didn't do any probability, and I wanted to start probability today. So let me start from this one, and we'll work our way upward to the 2024. A vendor has 15 apples on a tray, 5 red and 6 green, and 4 yellow. The customer requests 3 apples, but does not specify a color. Go ahead. All right, go on, working a few minutes. I'll work out that in the meantime. Oh my screen cut off too? All right. So the customer requests 3 apples, but does not specify a color. Shazan, give me 3 of the probabilities or 3 of the combinations that we can have for the apples chosen, 1 of each color. Go ahead.
What kind of probability first?
You didn't do, I didn't do probability?
No,
If I know,
All right. So, here what, right? In the bag, we have 15 apples. On a tray, 5 red, 6 green, and 4 yellow. So every time I pick an apple, the number of apples in the bag reduces. So the first combination that I could have a red apple, then I could have a green, and then I could have a yellow. So the probability of getting a red apple is 5 over 15. The probability of getting a red and a green, and mean to multiply, would be 6 out of 14. Because now instead of 15 apples, I have 14. And the probability of getting a yellow would be 4 out of 13. You all understand that?
yeah,
Right.
that's
So let me work out that. 5 over 15 by 6 over 14 by 4 over 13. How much is that?
0.04,
4 over 91.
0.04, yeah.
Yeah, 4 over 91. Now, this is one combination. So I could still choose red first, right? I could still choose red first. So the probability of getting the other 2, instead of picking a green second, I could pick a yellow and then a green. I still pick red first. So this would be 5 over 15 by 4 over 14 by 6 over 13. Work out that. Did you all get 4 over 91 as well?
much.
Right? So that is 2 combinations. Now, let me say that I didn't choose red before. If I didn't choose red first, my options are green first or yellow first. So green first or yellow first. So if I choose green first, I can have red and yellow. And if I choose green first, I could have yellow and then red. So work out that for me. And then my last option, if I choose yellow first, I could have green and then red. And then the last one, if I choose yellow first, I could switch it around and get red and green. So work out the probabilities for me. Right, let me know when you all are ready, okay?
Yes, I'm done.
All right. So you realize for all the probabilities, it is 4/91. Did you all get that?
Yes, miss.
So
Yes, miss.
over 91. So the probability of choosing apples, each of one color, would be 24/91. Did you all get that when you add up all? Check it and see.
Let's leave it in decimal point.
Well, here's what, Micaiah, you could do it in decimals, but for probability, especially probability, it's better to use it to leave the answer as fractions. Because remember, is teachers marking these papers, right? And somebody might just overlook that. You might put 0.26, they might overlook that, give you it wrong, whereas Shazad on the other side might put 24/91. The person who marking it probably late in the night give Shazad the mark and they give you yours. So especially for probability, try and put it in fraction form, right? Anything else you could use decimal, but not the probability. Because it's hundreds of scripts all over the Caribbean that are being marked and that uploaded on a computer screen. So remember when somebody tired and all too, try and put it how they want it, right? So the probability that they are all of the same color. So we could have red, 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 or we could have green, 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 or we could have yellow, yellow, yellow. So the probability of red would be 5/15 multiplied by how much is that? What's the probability of choosing our next red?
4/14.
4/14 and one more red, Shazad.
3/18.
Right. Micaiah, the probability of choosing a green.
6/15 by 5/14 by 4/13.
4/13. Shazad, probability of yellow now.
4/15.
Yeah.
3/14.
Mm-hmm.
And 2/15.
Very good. Check it up, multiply it, give me the answer.
Finishes.
That's all right. Here we have the word. We get a pretty big number. Does that tell us when you're ready? Okay, is there a function in a calculator that could change from decimal to fraction?
Let's face it.
Is there a function in the calculator that can interchange between decimal and fraction?
Yes, ma'am.
All right, so you could use that.
Someone.
All right, so the answer is 34 over 455. Did you all get that?
Yes, ma'am.
Right, so that
Yes, ma'am.
right. So what I will do next week, right? I will give you some notes on probability, and we will do some more questions, and we will see what other topics we didn't touch on, right? And we will try and tidy up all the loose ends, as well as I encourage you all to join the class on each Sunday as well once you are available. And before the end of the week, I will try and update the Google Classroom so you could try and look at the material that was covered. All right, so I'll see you all on Sunday. You all enjoy the rest of your week and good luck in the exams if exams have started, okay?
Yeah,
All right, bye-bye.
Bye, ma'am.
Bye-bye.